Hello ladies and gentlemen, what's up? It's Papa Bale. Welcome to the channel. So I turned my DC motor into a DC generator motor generator. You know, it does the same thing. What I want to say is it's going to generate solely from the magnet induction, from the magnet passing the copper on either one. The drive, which is cardinal 180 and then a 90 degrees. And then the generators are the other four, the ones where the magnets are right now. Sweet. Alright, so I'm going to do some AC generation here. And turn it on. I want to get this one in there because it's got the trigger in it. Leave the other three kind of outwards a little bit. Got our output from the SSG. I'm going to snake around. I'm going to describe the generator real quick. We got 18,000 turns, 32 gauge. Then we got 11,000 turns. That one has a core. 18,000 gauge turns has a core. And then we've got a Litz wire coil with 20 and 26 gauge. And that's all in series. And then there's a 32 gauge dual coil right there. It's a bifilar 32 gauge 1-to-1. Not exactly sure how many turns are in that one. Fills about half the bobbin though. So I'd say probably around 3,000, so 6,000 total turns. Let's see how much we're generating. Wow, dude. Let's look at the scope. Look at that. That's freaking beautiful. Very like pointy wave there. We're almost at 1,000 top to bottom. That's awesome. Heck yeah. Now let's there we go. Got that little echo in the that's pretty cool. $320 AC volts, man. That's crazy high. Alright, well, for like this, I've never seen it like that. It's always been around like 200 something. But that's awesome. Let's check the amps output. Wow, dude. Wow. like almost a full amp. That puts that at like 317 watts. That's pretty awesome. Heck yeah. Alright, let's cut it. And now I got the trigger coil in there good, so if it's going to run on any of that power that's being generated, it's going to be timed properly. Because all of the energy is being dumped back into the power input of this. And it seems to be chilling out rather quickly. So we may have found like a break. But I want to try and find a way to put it back in there to make it like run itself for a little while. And I guess maybe it is doing that right now, but I think it can coast like way better. We'll see. We're gonna check it out. It's just starting, but it sounds like it's almost over. And yes, there's a lot of friction in this. It's resting on a bearing. Okay, it is lying on top of a bearing. I have a magnet on the bottom of this thing, and when I put another magnet on the table, it'll float like right there on the shaft, but it's usually pretty high on the shaft. And usually the magnet is off by a little bit, but I've got this new disc that I'm going to use to center it, and it's pretty awesome. So you put this on your toroid, and then there's a 1/4 inch hole in the center, and it's like dead center, laser cut center. So it'll be pretty dang close. I think that's pretty awesome. That we can generate almost 1,000-volt peak to peaks on the oscilloscope. Let's look at the voltage a little bit right now. See how it's going up, like, but substantially. Like one jump was 3 volts, but then it's going down substantially as well. And getting slower and slower. But I mean, that's what it's supposed to do. It's not supposed to go forever. This isn't. This is just supposed to go longer or run longer. And if there's any correlation between the voltage on this meter and the RPMs, which I believe there is, then when it goes up, that means it's running on what I like. Each coil has a capacitance when it's moving for motion, and when that capacitance runs out, it'll stop moving. But since there's lots of things in play here. When the copper is up close like that, puts a lot of drag on the rotor. So the least amount of drag would be having no copper at all. You get what I'm saying? So with this much copper up there, yeah, pretty cool. All right. Thank you very much. Look at that. Just from it rocking back and forth. There's some latent current or something in this thing right now. Because I got I got a really bad shock from it earlier. It was it was still moving, but it was like, yeah, I grabbed it and it was bad. It was a clip. This clip, as a matter of fact, it was just clipped to this wire right here, and the other end was dangling off. I'm not sure what it was touching, but it grounded, and I was like, oh man, it jolted me pretty good. All right. Well, thank you very much. Bye now.